So we all know that code is basically just a list of instructions, right? But have you ever stopped to think about how it actually does anything? Well, that's exactly what we're digging into today. We're talking about operators, the powerful action words of programming. I mean, think about it. You've got your data, numbers, text, whatever. It's just sitting there. How do you get it to do math or make a comparison or decide which path to take? How do you breathe life into that static information and make a program that actually works?
The answer, my friends, is operators. An operator is just a symbol that tells the computer to perform an action on some values. And those values it's working on, we call them operands. It's kind of like this. If your data is the raw material, operators are the gears in the machine, the things that actually do the work and transform it into something useful.
All right, so here's the game plan. We'll start with the everyday essentials you'll use all the time. Then we'll see how to use them to build logic and store information. After that, we'll check out some specialist tools and cover the one golden rule you absolutely cannot forget. And we'll wrap it all up with some pro tips to help you avoid common mistakes. Let's do it. Okay, let's start with the operators that are going to be your best friends. Seriously, you'll be using these constantly. Think of them as the hammer, screwdriver, and wrench of your programming toolbox. They're the absolute essentials. So first up, arithmetic operators. Now, a bunch of these are exactly what you'd expect from math class. You know, plus, minus, multiply. But there are a few really cool ones in here. That percent sign, that's modulus, and it gives you the remainder of a division. It is so useful for things like checking if a number is even or odd. And that double asterisk, that's for exponents. So 2 double asterisk 3 is 2 to the power of 3. Now here's a really important one to get right. The difference between regular division and floor division. A single slash gives you the exact answer, decimal point and all. We call that a float. But the double slash does the division and then just chops off everything after the decimal, giving you a whole number, an integer. It seems like a small thing, but trust me, knowing which one to use can save you from some serious headaches down the road.
Okay, so our toolkit lets us do math, but what about asking questions? That's where comparison operators come into play. They let us take two values and compare them. We're literally asking the code a question, like, hey, is 5 greater than 3?
And you know what? The answer is always a simple yes or no. In programming, we call that true or false. There's no maybe. There's no in between. So, is 5 greater than 3? Of course it is. So the code sees that expression and just says true.
Here are the main players for making comparisons. Now, watch out for this one. The double equal sign, equals. That's how we check if two things are equal. A single equal sign does something totally different, which we'll see in a sec. The exclamation point with an equals, not equal to, and then of course you've got your classics, greater than, less than, and the or equal to versions.
All right, so we can do math and we can ask questions. That's a great start. Now let's see how we can chain these things together to make some really complex decisions, and, super importantly, how we can remember the results.
Logical operators are basically the glue that holds our questions together. And is strict. It demands that both conditions you give it are true. Or is way more chill. It only needs one of the conditions to be true. And not. It just flips the result. So not true becomes false. This is how you start building real logic, like checking if a user's age is greater than 18 and if they've accepted the terms of service.
And here it is, the single equal sign. This is the assignment operator. It's not asking a question, it's making a statement. It takes the value on the right and stores it in the variable on the left. The other ones, like plus equals or minus equals, are just awesome shortcuts. Instead of typing x equals x plus 2, you can just type x plus equals 2. It's cleaner, faster, and makes it really obvious you're just updating a value, like adding points to a score in a game.
Okay, we've covered the everyday tools. Now let's look at the specialists. You're not going to reach for these every single day, but when you have a very specific job to do, they are incredibly powerful and the absolute best tool for the task.
So identity operators, is and is not, are super strict. Here's the deal. You might have an identical twin. You both look the same, but you are not the same person. The is operator checks if two variables are pointing to the exact same object in the computer's memory, if they're the same person, not just identical twins. Membership operators, on the other hand, are way simpler. They're just for searching. Is the letter P in the word apple? Yep, it is.
And for those of you who really want to get under the hood, there are Bitwise Operators. These guys work directly on the ones and zeros, the binary code, that make up numbers inside the computer. They are wicked fast for really low-level stuff, but honestly, for most day-to-day coding, you can just file these away for later. Trust me, you'll know when you need them. All right, everyone, lean in for this next one because this is a biggie. Understanding this one single rule will save you from pulling your hair out for hours trying to fix weird bugs. We are talking about the order of operations, or what programmers call operator precedence.
So let's do a little pop quiz. What do you get when you calculate 5 plus 2 times 3? Now, your first instinct might be to just work left to right, but is that right? This right here is where precedence is absolutely everything.
And here's the classic mistake. If you just go left to right, you do 5 plus 2, which is 7, then multiply by 3 and get 21. But that's wrong. Because of precedence, multiplication has a higher priority than addition. It gets to go first, so the computer actually multiplies 2 and 3 to get 6, and then it adds the 5, giving you the correct answer, 11. Big difference, right?
So here's the official ranking. You might remember something like PEMDAS from school. Parentheses, exponents, multiplication/division, and then addition/subtraction. And you can see that comparisons and logical operators come even later. But honestly, here's the best rule of all. If you are ever in doubt, just use parentheses. They are number 1 on the list, so they always win. It makes your code way easier to read and guarantees the computer does exactly what you want it to.
Okay, to wrap things up, let's cover a few pro tips and common traps. We'll revisit that subtle but super important difference between two types of equals, and a few other cool concepts that can make your code way smarter if you know how to use them.
So let's really nail this down. Double equals checks for equality. It's asking, are the values the same? It's like having two identical copies of a book. They have the same words, same cover, they're equal. The is operator checks for identity. It's asking, are these two variables pointing to the very same object in the computer's memory? That's like two people pointing to the one and only copy of a book on the shelf. It's a much stricter check.
And here are a few more cool things to keep in your back pocket. Chain comparisons are just a super clean way to check if a number is within a range. Operator overloading sounds complicated, but it just means a symbol can do different jobs based on the context, like how the plus sign adds numbers, but it glues strings together. And short-circuiting? That's just the computer being efficient. If it's checking an AND statement, and the first part is false, it doesn't even bother checking the second part because it already knows the whole thing has to be false. Pretty smart.
Okay, so let's do a super quick review of our new toolbox. We've got arithmetic operators for all our math needs. We've got comparison operators to ask true-false questions. We have logical operators to combine those questions, assignment operators to store and update our data, and then our specialists, identity to check memory location, membership to search through things, and the heavy-duty bitwise operators for low-level binary stuff. That's the whole shebang.
You know, it is pretty amazing when you stop and think about it. Every single piece of software you use, from a simple game on your phone to the most complex artificial intelligence, is built using these simple, powerful symbols. They really are the fundamental building blocks of everything. So now that you know what they are, what are you going to build?